Now we'll do analysis of a quick sort. Before discussing time and the space complexity, I want to discuss some example. See, mostly people get confused if there are too few elements, like 2-3 elements are there, then how quicksort can work on it. So I'll take a small list of 3 elements and show you how quicksort can work on it, and also 2 elements and show you. So let us take 3 elements. Suppose the elements are 20, 10 and 30. This is infinity, this is pivot, this is I and J. This is the initial setup. We have to find the sorted position of 20. Right? So let us start. Using I, find out any element that is greater than 20. Is it greater? No. Is it greater? Yes, found. Using J, find out any element that is smaller than or equal to 20. Is it smaller? No. Is it smaller? Yes. We got the positions for I and J. But now I has become greater than J. If I is greater than J means this pivot will get swapped with the element at J. So 10 comes here, 20 goes there, 10 this side, 20 that side, 30 in its own place. This is infinity. From here the list is partition. There is only one element this side. There is only one element. Include this infinity is ignorable, right? So there is only one element. That's all. Now this one element is sorted, and on the either side we got one element. So this list is sorted. If we perform quicksort on this, quicksort will not work upon them because it will work at least there are 2 elements. So this was the example of 3 elements. Now let's take the example of 2 elements. Suppose I have 10 and 20. That's all. This is infinity. How quicksort will work on this? First element is pivot. I is on first element, J is on infinity. Using I, find out an element that is greater than 10. This is found. Using J, find out an element that is smaller than or equal to 10. Is it smaller? No. Is it smaller? No. But it is equal. Okay, stop here. I became greater than J. So we will not swap I and J element, but we will swap pivot with J. Pivot is also same, J is also same. So it is swapped with itself. So like if this is low and this is high, so A of low is swapped with A of J. So same element will swap with itself. Nothing will happen. 10 remains there only. So now this is partition here. So this 10 is sorted. Then on that side we have just 20. Ignore infinity. So there is single element. No need to sort it. So that's all. It is working on 2 elements also. Now I'll take one more example. If the elements are already sorted in ascending order, then how quicksort works? So here is a list of elements which are already sorted, and if we run quicksort on this, let us see what happens. First it will select this as pivot, I here and J here. Using I, find out any element that is greater than 10. So this is found. Using J, find out any element that is smaller than or equal to 10. Is it smaller than 10? No, 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 no. Yes, equal. This is low and this is high, right? So J and I. So I became greater than J. So interchange pivot element with J. That is interchange element at L with J. So it is interchange with itself. Then the list is partition. How many elements we get on this side? Nothing else. Then how many elements on this side? We get all these elements. 20, 30, 40, 50 and infinity. So from here partitioning is done, right? You know the procedure. Partitioning is done. Left hand side, nothing. Right hand side, all remaining elements. That is, if you say these were n elements, then these are n minus 1 elements. Then next, we have to continue sorting. Select this as pivot. This is low and this is high. I is here, J is here. Using I, find out any element that is greater than 20. Yes, found. Using J, find any element that is smaller than or equal to 20. It's not smaller, not smaller, not smaller. Equal, found. I is greater than J. So we got a partitioning position. Interchange element at low with J. Means pivot element swapped with J. So it is swapped with itself. So no change, element remains there only. Partitioning is done. You remember J, partitioning is done. So how many elements on left side? Nothing is there on the left hand side. Remaining all on the right hand side. So the remaining elements are 30, 40, 50 and infinity. Now how many elements are there? N minus 2 elements are there. Then select pivot. I here, J here. Using I, find out any element that is greater than 30. So it is found. Using J, find element smaller than or equal to. Not smaller, not smaller. Yes, it's equal. So stop here. Interchange with itself. Partition the list. So 30 is gone. Remaining 40 and 50 are infinity are remaining. Now how many elements? Two elements. Then select this as pivot. I here, j here. Move I to find greater element. Yes, found. Move j to find smaller or equal. Same element. Partitioning is done here. What is left? 50 and infinity. One element left. For one element, no need of sorting. So you can see this is how quicksort is working on a sorted list. It means first time when n elements were given, next time nothing was there on this side, n minus 1 elements that side, then again nothing on this side, n minus 2 elements this side, then this has go on reducing, then finally 2 elements this side, right? No elements this side, 1 element this side and 0 element this side. Now let us find out the time. See what it is doing. First time n elements were compared. I was moved here, but j was brought from here till here. N comparisons. Again here also j was brought from infinity till this one. N minus 1 comparison. So as many elements are there, that many comparisons are done. So first time n comparisons are done, then n minus 1 comparisons are done, n minus 2, so on, then 2, then finally 1. So total how many? 1 plus 2 plus 3 plus goes on to n comparisons. I am adding all these comparisons. So this is how much? N into n plus 1 by 2. So this is order of n square. So this is the time complexity of quicksort. For what? Sorted list. If the list is already sorted. So actually this is the worst case time of quicksort. This is worst case. If the list is already sorted, it is taking n square time. And the list is sorted in ascending order. Then one conclusion. If the list is sorted in ascending order and we are trying to sort it using quicksort, it performs these many comparisons. So that are n square comparison. So the time complexity of quicksort is n square. I'll remove this, then we will see second case. I have taken a list in descending order. Let us understand how quicksort works on this one. Let us sort. Few elements I will sort. This is selected as pivot. I is here, j is here. Using I, find out any element that is greater than 50. Is it greater? No, not greater than 50. No, no, no. Yes, this is greater. Infinity is greater. Then using j, find any element that is smaller than 50. Is it smaller? Yes, this is smaller. But I became greater than j. So interchange pivot element with j. So if you send it here, then 10, 40, 30, 20 and 50 and infinity. This element is sorted, these elements are remaining to be sorted. 50 is sorted. How many elements on right side? Nothing is there. Infinity is not an element. So nothing is there on the right hand side. So if you see now, the previously I have shown you a tree. So this n, now this side n minus 1 elements, this side nothing is there. So as the list is partitioned, it is partitioned into 2. So but one of the list is empty, nothing is there. So on these elements if we perform, then 10, 40, 30 and 20 if I perform, this is selected as pivot. I is here. Assume that infinity is there. J is here. Okay. That 50 will act as infinity. So I will not show 50. I will show infinity only. Using I, find out any element that is greater. Using j, find out an element that is smaller than or equal to 10. Is it smaller? No, no, no. Yes, found. I became greater than j. So pivot element L is swapped with j itself. So one element is sorted. Remaining elements are these. So now this time left hand side nothing. Everything is on the right hand side. So on this side nothing. N minus 2 elements on this side. So if it is in descending order, then one time partitioning was done at the end of this list, right hand side. Then next time it was done on the left hand side. So if partitioning is happening on leftmost position or rightmost position, then the time taken by quicksort will be, if I continue this, you know the answer, n square. Yes. So the time complexity of quicksort will be n square. So this is the worst case time of quicksort because the partitioning is happening on any one end of a list and one of the list is being empty. All the rest of the elements are coming in one single list. So that's why time is order of n square. And this is worst case time of quick sort. So finally, now conclusion. Now one of the conclusion again. Elements, if they are in ascending order or descending order, quick sort will take n square time.